In this video, we're going to take a look at something called gerrymandering. So gerrymandering is a process of drawing congressional boundaries to favor one party or group over another. We talked in the last video about apportionment. Apportionment is this process for divvying up seats between different states or territories or so forth. So for instance, North Carolina currently in 2023 receives 14 congressional seats. If you were to look at a state like Maryland, that would be only 8. They're a smaller state by population. And so each state gets a different number of seats based on their size. That state is then responsible for divvying up those seats, so drawing those congressional boundaries. That process is unevenly distributed throughout the United States. So some states will have a nonprofit committee look at that and divvy up in a fair way. So maybe they just take the state and they break it up evenly. So for instance, here I have a state drawn. It's a rectangular state. And this state, we can see that we have each little different district. And so how do I choose to break up these little areas, these little households? Well, one way I could do it if I was to break this up evenly is maybe I just break it up by rows or by columns. And so I break it up very linearly. Now, there's not a lot of rules deciding how I get to break up the state. The only rule is that each break or each region has to be even to every other region. So if I have congressional seats 1 and 2, congressional seat 1 is voted for by 100,000 people, then congressional seat 2 also has to be voted for by 100,000 people, or have to be 100,000 people living in that district. So that's really the only rule, is that those districts do need to be even in terms of population, not in terms of geographic areas. So we're going to see that in just a second. So this little block, let's break this up in a number of ways. And so there are 64 blocks in this this diagram over here to the left. And so I've used red and blue as per the traditional party seats. So red traditionally represents Republicans, blue traditionally represents Democrats. And so in this system, I have evenly broken it up. So there are 32 reds and 32 blues. And so what we're going to do is we're going to say there are a total of 8 seats to be given out. So if we think about how this is broken down right now, make that look a little bit clearer. There are an even number of reds and blues. And so what would we think? Well, it seems like those 8 seats should be split 4 and 4. 8 total, 4 blue, 4 red. That seems like a pretty fair distribution. Now, pretend this is a map. When we're drawing our congressional districts in, there are, like I said, very few rules. They have to be even number of seats. So if we think about 64 total blocks, or we'll say 64 households, 64 divided by 8 total seats means that there needs to be 8 blocks per seat or per district. So when I want to create my districts, they have to contain sets of 8. There's one other rule that says that the districts have to be attached. I can't say, let's say, let this guy be in with these other 4 people here, and then we'll include this person here, and then I'm going to include maybe one other seat over here. I'm not allowed to do that. I'm not allowed to just randomly group them. They have to be attached. But I don't have to draw nice pretty shapes either. So for instance, maybe I choose to draw this as a shape. There's one district. Well, that shape actually looks pretty nice. It's all nice rectangular. I'm going to draw another one right next to it. This seat right here, another nice rectangular seat. Both contain 8 seats. And notice this would be 4 red, 4 blue, 4 red, 4 blue. So in both of these, actually, they would be tied. Those 2 candidates would tie, and they'd have to go to some sort of runoff process. How often do ties occur? Not super frequently. If we think in North Carolina, each seat's represented by something like close to 300 some thousand people, or make sure that's right, a little over 300,000 people. It's very rare that 300,000 would break it down exactly as 150,000, 150,000. It does occur. There have been ties in races before, and those could be decided by a coin toss or by a runoff or by any number of selection processes. That's up to the state. So we can see that, again, if I'm drawing my nice rectangular districts here, we're getting a lot of ties. And so if we were to count up just based on those rectangular districts, we have a tie here, 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 another tie, another tie. Oh, and finally in the last one, this first seat over here, this would be won by Republicans because we can see that they control, I'm saying Republicans, Reds, they control 5 out of the 8 seats, and then over here the Democrats would have 5 out of 8 seats as well. And so these ties, we'd have to go into some sort of runoff, coin toss or something, and then Republicans and Democrats, or Republicans and the Reds and Blues, I'll call them Reds and Blues again, they would split those last 2 seats. And so this seems to be a pretty fair method. We predicted that we should have four blue winners, 4 red winners, and we had nearly that. Maybe we choose to do it slightly differently. Maybe we want to break it up based on rows. Well, my row here, and just keep doing this. We're going to see that we get a total of 8 total rows. So the first row, we have 4 reds, 4 blues, so we have a tie there. We have another tie, we have another tie, we have another tie, we have a tie, and in fact, they all tie under this method. And so it does seem to be pretty evenly broken up. And that seems fair, right? Because if there's exactly half the reds, half the blues, it makes sense they would tie. Or at the very least, again, if we have that district maybe of 300,000, we wouldn't have an exact tie of 150,000, but it might be something like 152 and 148,000. And so we'd get a winner one way or the other, but it'd be very, very close. We wouldn't expect to have, of 8 seats, we wouldn't expect the Republicans to win, or the Reds to win 7 of them and the Blues to win just 1. That would seem to be a little bit unfair. And that's where gerrymandering comes in. So gerrymandering, just the same way as divvying up this graph a second ago, politicians are sitting around sometimes divvying up that shape. And so, like I said, one way to divvy the shape up is to hire an independent commission and say, okay, do it fairly. Don't choose preference, just find a good way to break it up. We have to have these attached regions with even numbers of households, but maybe we want to do it based on, lines of latitude, longitude, or maybe there's some rivers or townships that we could break it up around, or just kind of put a grid on a map, and we could do it that way. But then sometimes it's not so fair. Maybe the politicians decide we want to do it and we want to help our party out. So if I'm in the blue party, I want to have as many blue winners as possible. Or if I'm in the red party, I want to have as many red winners as possible. So let's come in here and let's draw some maps so that we can maximize the number of winners for either the blues or the reds. Let's first try to win for as many blues as possible. Now, I'm going to do something that seems a little bit strange. To do this, I'm actually going to start by grouping as many reds as possible. And you say, well, wait a minute, why would I want the reds to win? So as I've just drawn it, I've drawn too many. Let's try that again. So that'd be 6, 7, 8. So I've drawn this grouping right here. So I've guaranteed the reds to win this district right here. Guaranteed loss for the blues. And as someone that's trying to draw this for the blues, you say again, why are you doing this? This seems like a terrible idea. Well, what I've just done is I've isolated a bunch of red voters. So that allows me to spread the blues out so that hopefully they can win more seats. Let's see what I'm talking about. If each seat is 8 total blocks for 8 total households, that means to win a block, I need 5 votes. So I've got to place 5 blues in each district to win. So I see a group of 5 right here. I'm going to include this group of 5 with a group of 3 reds. Let me draw that a little bit prettier. So 1, 2, 3, 4, 5, 3 reds. And so right here I've created a grouping with 5 blues and 3 reds. So blue is guaranteed to win. Next, I'm going to have to get another group of 5 blues. I'm going to get a little bit creative in my drawing this time. So if I just take these 5 blues, well, it's only with 1 single red. And remember that I'd really like to be able to include at least 3 reds each time. So I'm going to group, let's see, these 3 reds let me take, because there's already one red down there, I'm going to group these two reds. I'm going to include these 1, 2, 3, 4, 5, and then this red as well. And you might be looking at that, well, saying, wait a minute, I thought they had to be attached. And this is something that was kind of litigated. As I've just drawn it, let me maybe draw that in a different color so you can really see what I've done. Let me use green here. So 1, 2, 1, 2, 1, 2, 3. I need to include that one. 3, 4. I forget how I just did it now. So let's try this one more time. I can't break them off. Let's do this slightly differently. 1, 2, include this one. 3, 4, 5, 1, 2. All right, so I've just created this green district. And what I was just saying a second ago is, remember I said that things had to be attached. Now you might be looking at this saying, well, you know, this red's kind of separated and it's continuous through a point. And this is kind of a weird definition that politicians created. They fought this in the courts. Point-wise continuity. So, you know, are these two things actually touching? Well, they are touching through a point, but a point doesn't have any area, so you would make the mathematical argument of no. But the court said, oh, no, good enough. The fact that these two districts, these two seats, touch that single point, that is good enough. Now, what I have done here is I've excluded this group of blues 3s here. So maybe I might have to come back in here and draw this a slightly different way. So, as you can see, it's not a quick, easy process, but we are still, let's do it like this. 3, 4, 5, 1, 2, 3. So I'm going to make that green district a district. And so now in that green district, the blues have won that. Okay, now I'm going to form another one. So I have these 3, 4, 5. I need one more, and here I have no choice but to get a 6th blue voter. So 1, 2, 3, 4, 5, 6. But the blues win that district. Then we have, let's say, 1, 2, 3, 4, not quite enough to win. 1, 2, 3, so I must steal one of that group. And so here we have, this is another blue win because I have the 5, 1, 2, 3, 4, 5 blues and only 3 reds, so the blues have won that grouping. This next one, let's see if we can do this. We have to get a little bit clever about how we're going to do it, but I think we can do it. 1, 2, 3, 1, 2, 3, 4, 5. So the blues would win this grouping. And so then I still got to break up this last group. I don't know. Let's see. 1, 2, 3, 4. 1, 2, 3, 4. Have I messed up some of my counting? Apparently. 6. 3, 4. 1, 2, 3, 4. So I think if I break this one up, I have messed something up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I just was missing this one. Let me clear up this boundary line right here because that's a little bit confusing to me. So I want to make sure I'm including only the 8. Okay. So then I need to make sure I have 5. So if I include, well, let me even restructure this slightly differently. I'm going to include this one here. So now I have 5 blues and 3 reds. So then I can have 5 blues. 1, 2, 3, 4, 5 blues and 3 reds here. So that's another blue win. And then the reds have lost that one here. The reds have won here, that one there. So I've had to take a little bit of time and done a little bit of rearranging to come up with these different districts. But you see actually what I've created is 6 blue and 2 red. So not very fair by the looks of it. And it took me a little time to do that, but that's what these politicians are doing when they're gerrymandering, is they're sitting around kind of messing with boundaries like that. And they've gotten actually very good at it because they can have computer simulations help draw this out for them. But that's exactly what they're doing. I could do this from the red perspective and do exactly the same thing. I could say, okay, I need 5 red voters and 3 blues. So there's a red win. And I need 5 red voters and 3 blue voters, and there's a red win. And I'm just going to go ahead and write this group off here. So let's see best way to do it. Well, let me keep just playing with the idea of 5 and 3. 1, 2, 3, 4, 5, and 3. So that would be another red win. And then I'm going to take 1, 2, 3, 4, 5, and 3. There's another red win. And then let's do 1, 2, 3, 4, 5, and 3. There's another red win. 1, 2, 3, 4, 5, and there's another red win. Now that one I might run into a little bit of trouble because I'm not going to be able to include those last groups of blues. So maybe this one I'm just going to write off as my blue district. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be a blue win there. I've lost one. But then I might be able to include these 3 over in this one through that pointwise continuity. So there's a red win, and then there's another blue win. And so we've ended up with 2 blues and 6 reds. And so you might be saying, well, this seems like a lot of time and effort. Who's actually doing this? Well, North Carolina for one. This is a map that was drawn back in 2010 after the 2010 census used in the 2012 election. And you look at this map and say, well, they didn't use any of that nice even chopping that I did a second ago when I was just using rows or columns or boxes. It looks really strange. Why do we have this one district that's running all the way up here? Well, what the Republicans have done is exactly what I did in that first case where I just grouped all those reds together. They said, okay, let's find all those Democratic voters. They live in Goldsboro and then down through Charlotte in this stretch right here. So let's group all of them together so that we can have a lot of blue voters right there. And then that leaves a lot of red voters to kind of spread out over the other areas. Similarly, you're going to see the triangle area. In here, we got Raleigh, this is Greensboro area, and then we've got Raleigh sort of over here into Wilmington over there. So kind of edges of, not really Raleigh there either. We have Raleigh through here, Greensboro down into some of the Raleigh, Sprawl, Cary and such. Then over here we have a little bit into Wilmington and going up into northeastern North Carolina. So they've grouped all of those voters in a really efficient manner. Let's look at the actual numbers. So in 2014, this is the 2014 map, there were 10 Republican candidates that won, 3 Democrats. I pulled the numbers for 2012 because I think this is even more striking. So in 2012, there are a total of 2,219,165 votes cast for Democratic candidates, 2,143,000 votes cast for Republicans. There are some other independents who were cast, but those were the ones for just Democrats and Republicans. There are a total of 13 seats. So if we look at the ratios, Democrats won 2,219,165 out of, if you add those two numbers together, it's a total of 4,362,283 votes. And so that means in terms of the percentage, they won 50.87% of the vote. The Republicans won 2,143,118 out of the 4,362,283. Or, oops, let's type something. Give me one more second. Um, 49 0.13% of the vote. So if we're thinking about seats, they're very nearly split. Of course, there's 13 seats. No one party is going to be able to have exactly the same number as the other. It's going to have to be a little bit out of balance. But if we take these and multiply by the 13, just to see how many seats we would expect, we get 6.39 for the Republicans. The Democrats, we would get 6.61. So maybe we say this rounds up to 7, this rounds down to 6. That's maybe what we'd expect in terms of numbers of seats. The actual distribution in this particular election, a little different than the map I have shown, it was 4 and 9. The Republicans had less votes in 2012, yet ended up with 5 more seats than the Democrats. If we think about that as a percentage, 4 out of 13, the Democrats won 30.7% of the seats, even though they won 50.87% of the vote. The Republicans won 69.23% of the seats, even though they won only 49% of the vote. So exactly kind of the opposite of what we would predict. We predicted the Democrats would have more seats, but in fact, overwhelmingly, the Republicans had more seats. And so how did this happen? Well, if we look at some of the data breakdown of this, they heavily jam these people into certain districts. So for instance, up here in North Carolina's 1st District, the Democrats won 250,000 votes, the Republicans won 76,000 votes. If you look at North Carolina 2, right here, so keep in mind that difference there was 180-ish thousand votes. North Carolina 2, the Republicans won 50,000 more votes. So more, but not nearly the same margin as in North Carolina 1st. If you look at North Carolina's 12th, which is a little skinny one in here, the Democrats won 246,000 votes, the Republicans won 62,000. So a deficit of about 60,000. The deficit about 180,000 versus the Republicans, the most they ever won by was about 60,000, and at times it is as low as 20 or 30,000. Now, the map I have shown here, the Republicans did win 10 seats. There was one election, North Carolina 7th, this region over here. In 2012, the Democrats won that by 500 votes. Well, in 2014, the Republicans were able to pick up those 500 votes that they were able to win. And that's one of the dangers is trying to spread your voters. Sometimes you spread them a little bit too thin and you lose one that you kind of thought you should win. Again, that 7th, notice how it's kind of drawn very oddly to make sure they get as many as possible. They were able to pick that up in 2014. And so that is a way that these weird maps, what we were doing just a few seconds ago, trying to draw these things in strange patterns, that is actually used to win elections. Now, if you say, well, now you're just picking on the Republicans, don't they all do this? Well, yes. This is an example of Maryland's districts. We can see that they have equally odd drawn figures. The 6th is quite a strange district. And so if we look at their vote totals, we can see that the Democrats won 1,481,000 votes compared to the Republicans' 832. The Democrats won 8 out of 9 seats. That seems a little bit funny given that those two numbers are so close. So let's do kind of the same calculations. Let's look at the Democrats and Republicans. So the Democrats, 1,481,895 out of a total of their 200, I added these beforehand, 2,314,217. So I'm going to do the division there. And so Democrats won 64.03% of the vote. Republicans should be about the opposite. It will be the 832,322 out of 2,314,217. Let me type this in the calculator. And so we have 832,322. And so the Republicans won 35.97% of the vote. If we do their expected seats, we'd multiply this by 8. I might do the Republicans first just because I have that number in my calculator right now. So they should win about 2.8 seats, or what we would think of as 3 seats. The Democrats would win about 6.2, or what we'd predict 6. Try that one more time. 5.2, or about 5 of the seats. That's what we would predict. But in fact, Democrats won 7, Republicans only won 1. And so if we do those percentages, Democrats won 87.5% of the seats, Republicans 12.5%. And those clearly don't match up with their percentages. So once again, we see that it's quite gerrymandered in the opposite's favor. So in this case, the Democrats were heavily favored. And we can see similar splits in those votes. So in the one seat that the Republicans won, that would be the big one over here on the Eastern Shore. The Republican candidate won 202,000 compared to 85,000, so over 120,000 more votes than the Democrat. And in all the Democrat districts, there's splits as close as 60,000, 50,000. There's some bigger ones too, but definitely not representative of the population as a whole. So this is argued, whether it should be done, shouldn't be done. Politicians are arguing about that. I'm going to let you make your own decisions. I'm just pointing out what's happening so that you can be informed. Now, let's see how badly we can really gerrymander things. We saw a picture, and we are limited a lot of times by the number or the placement of households. And so that is something to consider, is that a lot of times people do group themselves around like-minded individuals. For instance, going back up to North Carolina, I know that map a little bit better. Raleigh, Durham, Chapel Hill tends to be a very liberal area, a very democratic area. The rural parts of North Carolina, especially out east where I'm from, much more conservative. Charlotte, again, we have a large grouping of people there that just naturally by their placement are much more, the surroundings tend to be a lot more similar. They all tend to be a lot more liberal, a lot more democratic. So sometimes those patterns kind of naturally emerge just through where people tend to move themselves. But let's kind of ignore those party lines for a second. Let's look to see how many seats we can win. So I've made up 2 different parties here. We have the pink party and the gray party. There's 12,000 total voters in the pink party, and there's 8,000 voters in the gray party. We want to see how many seats these 2 groups can win at a minimum. There are 20 total seats. So the first thing we have to determine are the total number of voters. Total voters, we're going to add the 2 numbers together, 12,000 voters in the pink party, 8,000 in the gray party, and that gives us 20,000 voters. Let's think about how many voters are going to be in each seat. Voters per seat. So the way we do this, we're going to take the total number of voters, divide it by the total seats, and we can see that there's going to be 1,000 voters in each seat. Same way I did that first example where I had the 64 total regions, I had 8 seats, I had 8 voters, 8 households per seat. Done the same thing here, just in terms of the algebra. So if we think about what that means we need to win each seat, to win, we need more than the other candidate. So we're going to take the total number of voters per seat, we're going to divide it by 2, we're going to add a single vote. So that means we need 501 votes to win. 499 would be the other candidate. They obviously would have less. If it was an even 500-500 split, we'd have to go some of those goofy tiebreaker rules. So 501 guarantees us a win. That's what we need. So if we're looking from the pink party's perspective, they have a total of 12,000 voters. We need 501 votes to win. So if we take 12,000 and divide it by 501, we see that we get 23.9 total wins. Well, of course, we can't have more wins than the number of seats. So what this is telling us is that the pink party could win all 20 seats. They had so many more voters than the gray party that if they're to spread themselves out in the right way, they could win all 20 seats. They can't win the 23.9 because there's just not that many seats, but they could win 20 seats. Let's look at the gray party. They only had 8,000 voters. We're going to break up those 501 needed into the 8,000. And that means that they could win as many as 15.9, or can't really round up because we wouldn't have quite enough. That would mean they could win up to 15 seats. And you might be looking at that saying, well, wait a minute, I thought we would round up 0.9, we'd round that up to 10. But the problem is they're 0.1 short of winning that 16th seat. And so, it doesn't matter if you're one vote short. If you're one vote short, you're one vote short. So you're not going to win that last seat. So they could win up to 15 seats. If we would think about what we would expect or what should happen, the kind of the fair outcome, well, the pink would have 12,000 out of 20,000 times 12 seats, or they should win 12 seats. The gray would have 8,000 out of the 20,000 times 20, or 8 seats. That's what would be fair. But what we see could actually happen if we wanted to gerrymander this, the pink party could win as many as all of the seats, 8 more than they should have, or the gray party could win as many as 15 seats, 7 more than they should have. So they're not going to be able to win it all. They don't have enough support for that, but they could definitely throw the election in their favor based on these principles of gerrymandering.